Hi friends, this is Mr. Zarzik, and in this screencast I'm going to work through practice file 2-2. So if you need a copy, hop on Schoology and grab yourself one, pause the video, and then come on back once you have one handy. If I look at the instructions here, we're going to toss a ball. So it says it's tossed upwards with an initial velocity components of 30 meters per second vertical and 5 meters per second horizontal. The position of the ball is shown at 1 second intervals. Air resistance is negligible. G is 10 meters per second squared, so that's gravity. Fill in the boxes writing the values of the velocity components ascending and the calculated resultant velocities descending. Okay, let's get to it. All right, a little baseball player throws the ball up and to the right. All right, so these are the components. All right, so this would be like my Vy part, so the upward part, and this is the Vx part. All right. And then each of these is supposed to represent 1 second time intervals. So think like down here, we would start the stopwatch or the clock. So this would be like time 0. This would be like time 1 second, time 2 seconds, times 3 seconds, times 4 seconds, time 5 seconds, and then down here, time 6 seconds. Okay, and we have to figure out what's going on here. If we look at the 1 second in, okay, we see that that little sideways piece is still 5 meters per second. See, so like this is Vx, all right? This maintains 5 meters per second the entire time because, well, once it's in the air, the only thing that affects its motion is gravity. And gravity points down, which is not sideways at all, okay? And in fact, over here, I'm actually going to zoom in where it says gravity is 10 meters per second squared. To be more accurate, okay, I'm going to include a direction with this. I'm going to put a little negative sign, see, because we throw it up at 30 meters per second. Gravity acts downward, so we show that with positives and negatives. Okay, this is an acceleration, okay, that acts in our y dimension, so up and down, okay? Sometimes we just abbreviate it with g, but just so we see what's going on here. Anyways, so going back to this, okay, the acceleration is in the y dimension. The x dimension experiences constant velocity. So when I get up to this box up here, this would be time 2 seconds. Okay, well, this value here is still just, here, let's keep it black to stay consistent. This is still 5 meters per second. Okay, like my Vx does not change, okay? And in fact, when I get up to the top here, this is the ball at its apex, or the peak of the parabola. All right, it's still just moving 5 meters per second sideways. All right, so that part's pretty easy. Just we have constant velocity sideways. All right, our Vx does not change. Vertically, it's a different story. If we toss the ball up at 30 meters per second, okay, and again, I'm just going to put a little plus sign just to signify up at 30. All right, well, gravity's minus 10. So on the way up, gravity's working against our velocity, which has the effect of slowing us down at the rate of 10 meters per second per second. That's what meters per second squared means. All right, what it also means is that 1 second into our flight, okay, we're going to be going 10 meters per second slower than we were before. So when we get to 1 second in, we're not going 30 anymore. We're going 20 meters per second. This would be our Vy at this point of 20 meters per second. Let me put that a little closer. Okay. 1 second later, all right, so up here, we're getting closer to the top. Okay, gravity's again going to slow us down by an additional 10. So up here, we're only going 10 meters per second, see? All right, if I look at the very peak of this, all right, well, there's no upward arrows because at this point, gravity would have taken away another 10 meters per second, in which case our Vy, our vertical part of our velocity, has shrunken down to 0. See, this 5 meters per second up here, that's a Vx, okay? Like this is a Vx, all this sideways stuff, this is Vx, all this vertical stuff is Vy, all right? We start off moving upwards at 30. 1 second later, we're going upwards at 20. Another second later, we're going upwards at 10, all right? And then when we hit the peak, we're not moving upwards at all anymore, okay? So we've got all of our components. Right? The way down, okay, we can use that same kind of reasoning, that same kind of thinking as we did on the way up, all right? I'm going to start with the sideways part, see? Because, well, if we look at this, I mean, the pattern says it's 5 meters per second, 5 meters per second, 5 meters per second, 5 meters per second. If I look at the descending part of this, okay, well, now they tell us, oh, look, here's this arrow, and it's supposed to represent the ball coming down. As the ball comes down, it's moving down and to the right. All right, so I can think about this in terms of components. All right, so I'm going to draw those components. And we've used this trick before where you make a little box, okay, around the thing. And the corners of the box tell us how long to make the arrow. So the vector points down and to the right, so it's got a to the right component here. Okay, and it's got a downward component over here. Ooh, give me my arrow. There we go. Okay. There we go. It looks pretty good. All right. And the sideways component has been 5 meters per second everywhere else. Guess what? It's 5 meters per second here as well. That part hasn't changed. That's my little Vx. All right, and if I continue on with this, I'm going to use the same trick over and over again. I'm going to take and just make a little duplicate of this over here. All right, the sideways part of this is still just 5 meters per second. This is my little Vx here again. All right, and if I extend this down, okay, it looks good enough. Here, it gets straightened. Okay, still 5 meters per second. I'm going to do the same little thing down here as well. Ooh, come here. Listen to me, notability. Okay. There we go. Okay, so I've got the sideways part of my velocity over here. All right, now let's talk vertical. Sideways easy, 5 meters per second the entire time. Okay, vertically is a little trickier. Okay, on the way up, okay, gravity has the effect of slowing us down. So quick review. Plus 30, plus 20, plus 10, 0. Okay, gravity doesn't turn off, so the effect continues. All right, on the way down, all right, gravity is going to speed us up by 10 downwards. So after 1 second of moving back down, now my Vy is negative 10 meters per second. 1 second later, after 2 seconds of coming downwards, okay, I have now sped up again. So I'm going to finish my little box over here. All right, get my arrows right. Dash this out. There we go. Okay, here my Vy is now negative 20 meters per second. See, so like we're getting faster downwards. Okay, don't get confused by the negative. The negative is just the direction part. Okay, the speed is just the number. So it goes from 10 to 20. We're speeding up downwards. Okay, when I get over here, all right, I'm going to speed up again from minus 20 up to minus 30. Now, because I'm going to be meticulous about this, I'm going to take a copy of this downward arrow. I'm actually going to drag it over here because I know how long an arrow that has a speed of 30 should be. So I'm actually just going to draw a downward arrow that's the same length as my Vy over here. And then I'm going to drag it back over here just like this. Okay, and that's what I'm going to use to build my resultant. I'm actually going to build it from its components. And that's really what I'm doing with all of these, is I'm going to get to the resultant from the components. Okay, my components point down and to the right. This Vy here has a value of negative 30, so down at 30 meters per second. Okay, and the resultant arrow would point just like that. Okay, so this would be my overall velocity, which we're going to calculate here in just a second. All right, I'm going to go back. I'm going to start up at the top, okay, because I got 3 boxes that I need to do. All right, to get the actual resultant, the diagonal vector. Okay, I'm just going to use Pythagorean theorem. Okay, I'm just taking the sides of the triangle. See, like it's just a right triangle. Like it's just sitting right there if you can see it. Okay, so we can still get to use the formula. That's kind of nice. All right, I'm going to take the square root, okay, so of my Vx squared. So I'm just pulling this straight from the formula. Okay, so my Vx squared is 5 meters per second. So I'm going to take 5, I'm going to square it. I'm going to add it to negative 10 meters per second. I'm going to square that as well. 5 squared is 25. Negative 10 squared is positive 100. So like negative times a negative is a positive. All right, if I throw square root of 125 in my calculator, I'm going to get 11.18 meters per second. This is my V, okay? All right, I'll do the same trick over here. All right, to get my V, so I'm going to take 5 meters per second, which is my Vx. I'm going to square it. I'm going to add that to my Vy, which is negative 20 meters per second squared. Minus 20 times minus 20 is positive 400. So this is square root of 425, which, put that in your calculator, you get 20.62 meters per second. That's my V. All right, and then down here, one more time, all right, to get my V, I take the square root of my Vx squared, which is 5 meters per second, plus negative 30 meters per second squared. Negative 30 squared is 900 plus 25. Square root of 925 would be 30.41 meters per second. And again, that's my velocity. Okay, so we get a picture of what this thing is doing. Its vertical velocity is constantly changing because gravity, which is an acceleration, is happening the entire time the ball's in the air. Horizontally, no acceleration. All right. This is Mr. Zarzak. This is practice file 2-2. Thanks for watching. See you next time.